Hello, this is Alex Bountis, and in the next few slides, I will be presenting the assignment for managing machine learning projects, part of the course 2. So the project topic and the chosen ML application is an AI crop recommendation system that will suggest suitable crops to an amateur farmer tailored to their specific conditions. This is going to be narrow from a definition point of view. We'll start small. This model will initially be focused on a specific country only, for example, the United Kingdom, and this model will cater for small plots or allotments rather than big farming estates. So we'll evaluate the opportunity. We'll start by trying to answer those questions. Is there a problem? So after talking to allotment holders and conducting interviews and even running a focus group with allotment holders, the following pain points have been identified. There is little knowledge about the farming practices among the participants. There is little understanding of weather patterns and how those affect crops specifically. And failed crops tend to lead to overall disengagement with the plot with the allotment. Can ML help solve it, such a problem? Given the right data, an ML system, first of all, is feasible. As with most such systems, data is the key. Data can be sourced by the users themselves, by owners, and the owners often being councils, so there's plenty of data from the councils. Does someone care? With the cost of renting allotments going up, increasing yield is becoming even more important for a huge percentage of the holders. On top of the holders, of course, councils, which are the owners in most cases, they want to rent those plots out. They're looking for ways to make it more appealing, and it is really important for them as well. So really, with regards to the opportunity, it is a high business impact and high feasibility, but we'll cover this in the next few slides in more detail. With regards to the business understanding, first of all, we need to define the problem. That's exactly what we've done in the previous slides. The opportunity has been described before and is effectively what defined the problem. But let's talk about the success and what success looks like in this case. I mentioned the business impact can indeed be high. First of all, we get higher crop yield for the user, and that's measurable in itself, but it can also mean higher return on investment, which is also measurable. It is higher engagement from the users. We can also measure it as a higher satisfaction, something that can be measured with forms and feedback forms, and higher allotment renting percentage, meaning higher income for the owners or the councils in this case. Again, something that will be easily measured. There are some relevant factors to all this, of course. There's a domain expertise like farming, and there's the localized environmental data. And I'm not just talking about the weather data, where we can have forecasts from services, weather services, but also soil, crop availability, crop allowance, in depending on each council. So all that is important factors for success. With regards to our validation plan, using an agile approach to validate the proposed solution concepts, the following iterations are suggested, and it's going to be an iterative process, starting, of course, with our mock-up to solidify the business understanding and test with the users what it would look like, and then start using a small subset of historical data with that mocked-up model, effectively to confirm the data understanding and solidify even more the business understanding. Again, test with the users, get the feedback, and then move to the next step with real data for a single plot with that heuristic model. That can easily be tested if it's very localized on a specific plot. The domain expertise probably is already there. There is plenty of knowledge and it can be tested before moving to real data for a single plot with a full machine learning model for full evaluation, which is ready for piloting with the users, and before really going to the last stage and the last step effectively of deploying the solution to all intended purposes, which again is within a country and within small plots, small allotments. With regards to the machine learning system design, a few questions that we wanted to answer, cloud versus edge. This is to be a cloud system. Latency is not an issue here. Decision on crops is by definition an offline action. The user can connect to the internet at their own leisure and consider all their options there. There is also little privacy concerns. There's no specific user data is required, and that will affect the performance of the model. With regards to offline versus online learning, offline learning, no continuous retraining is required using its new data point here. Crops tend to have fixed conditions, and only when new crops are introduced or new features that training will need to be reintroduced. Also, the outcomes takes time to evaluate, so there's no immediate quality measurement of the output. With regards to batch prediction versus online predictions, now we picked online predictions. Reality is that while latency and immediate availability is not critical here, predictions still need to be generated upon request and not on a recurring schedule. Crops have different growth times, hence it has to be rather dynamic. And depending on the season where we hit this requirement to go and show new crops, the current conditions are different, and hence different recommendations may be needed. So it's not a scheduled one, it's on-demand online prediction. We'll close with the risks. One of the biggest risks here is data drift. Training using historic weather data here, which means that as we observe weather pattern shifts, as we all see, these are not really captured by the model. Of course, this is a slow change over time and will effectively degrade the model performance overall. Equally, soil conditions will change over time, as we are going to see higher crop yields or plot usage that will have an effect on the soil as well. So that's something that probably cannot be captured initially with the model. Another risk is the concept drift. Some users may opt to use the less care model, if you like, rather than optimum yield for their plot. After a while, this introduces shifts in the relationships between inputs and outputs, the way that users use their allotments. So thank you for listening, and that's it.